this is section 5 of chapter 4, and in this section we are going to continue talking about different ways to solve quadratic equations. Up until now we've talked about solving by graphing, we've talked about solving by factoring, and then in section 4 we talked a little bit about imaginary numbers and complex solutions and what to do when those come up, because sometimes they will. When parabolas do not have real solutions, they will have complex or imaginary solutions. Today we're going to talk about two different ways to solve. The first one is the square root property, which is pretty straightforward. And the second one, which is the main focus, is called completing the square. So we're going to add two new techniques to our quadratic equation solving arsenal. The square root property can only be used in very specific situations, but completing the square is something that you can always do. It will always work. Sometimes it's harder than others, but it is a technique that always works. Factoring, for example, does not always work. Sometimes quadratics are prime and they can't be factored. Square root property, we'll see in a second, only works sometimes, but completing the square always works. So our vocabulary for this section is completing the square, which we're going to see in a second. And then in order to do things with the square root property, which is the one that I told you works sometimes, we can only do this with perfect square trinomials. Perfect square trinomials come from the squares of binomials. So if I do a plus b quantity squared, I get a squared plus 2ab plus b squared. If I do a minus b quantity squared, I get a squared minus 2ab plus b squared. So for the square root property, we're going to be looking for trinomials that are in this form, that have a perfect square first and last term. And then the middle term is the square root of the first term times the square root of the last term times 2. We talked about these kind of trinomials in Algebra 1. All right, so we're going to solve this equation using the square root property. So we're going to start by analyzing our original equation. We're going to analyze it asking ourselves, is it a perfect square trinomial? So it's either a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So I always look at the first and last terms and I say, okay, are these both perfect squares? Yes. What's the square root of x squared? X. What's the square root of 49? 7. And then if I multiply that by 2, 2 times 7x is 14x. So that's 2ab. It matches this pattern. When that is the case, I do not need to subtract the 64 over here and solve. I could, but if I notice that on the left-hand side of my equation I have a perfect square trinomial, I don't need to do that because I know that a squared plus 2ab plus b squared factors into a plus b quantity squared. So since a is x in this case, and b is 7, the square root of 49, I know this is going to factor into x plus 7 quantity squared. And if I can do that, now the squared is my outside operation. And I can easily take the square root of both sides. So what I'm doing here is I'm doing the square root of this binomial squared. And on this side, plus or minus, don't forget that, the square root of 64. The square root of x plus 7 quantity squared is just x plus 7. The square root of 64 is 8. So I have x plus 7 equals plus or minus 8. So I know that x is negative 7 plus or minus 8. What I'm really doing right here is I'm saying, okay, x plus 7 equals 8, or x plus 7 equals negative 8. And then when I solve that, I end up with positive 1 or negative 15. So I have two solutions here. Remember, those solutions represent my x-intercepts. My x-intercepts, also called roots or zeros or solutions. If I substitute those into my original equation, we'll find out that they work. On this left-hand side here, I'm substituting 1 for x. 1 squared is 1. 14 times 1 is 14, plus 49. That does equal 64, so this one works. Over here, I do the same with negative 15. Negative 15 quantity squared is 225. 14 times negative 15 is negative 210. Then I add 49, and I get 64, so I can see they both work. So you guys are going to do the same thing. Try this using the square root property. Okay, you should have gotten C. And And here is the work if you need to look through how to do that problem. All right, let's try one more with using the square root property. In this case, it's the same thing. I notice I have a perfect square first and last term. Square root of x squared is x. The square root of 4 is 2. And if I multiply that by 2, I get 4x. And since it's minus, I know that it's going to factor into a minus b quantity squared. So in this case, it would be x minus 2 quantity squared. I can take the square root of both sides. Don't forget your plus or minus. Super important. And in this case, 13 is not a perfect square. So we just add the 2. So I have 2 plus or minus the square root of 13. And that is two different solutions. So if I wanted the exact solution or simplest radical form, I would leave it like this. These both represent my x-intercepts, but they're irrational. And if I wanted to plug them into a calculator, I would get my approximate solution. So pay attention to if you're being asked for the approximate solution, which is when you plug it in and round it, or the exact solution, which is when you leave it in simplest radical form. So again, exact versus approximate solutions. All right, try this one. The answer here is C, and there's the work if you need to look at that. All right, we're going to spend the last part of this video talking about something called completing the square. So we can only use the square root property if I can get my left-hand side to be a perfect square trinomial. If not, we can use something called completing the square. So basically, when we're completing the square, I have a squared term and my x term added together. And I'm literally trying to turn them into what we did back here. I'm trying to force them to look like this, to be a perfect square, but it's not a perfect square the way that it starts out. So what I'm going to do is I'm going to take this x term here and I'm going to cut it in half, and I'm going to stick it on both sides of my squared term, because x squared, if we were to draw it out like this, is actually a square. I take this B rectangle and I cut it in half. I stick it on both sides of my square here. And then I'm trying to figure out this number here. What number do I need to fill in that little bit of the square that's left? So our process is that we take half of B, because when I cut this B in half, it's going to look like this, because what happens here is I end up with x plus b over 2 quantity squared, and that's what I want. I want a perfect square. So I'm going to take my b, and I'm going to take half of b. I'm going to square it, and then I'm going to add it to both sides like this. So I'm going to add the b over 2 quantity squared to x squared plus bx. When I do that, it turns it into a perfect square trinomial, and I can rewrite it like this. So let's look at what that looks like in an actual problem. We're going to start just by figuring out what number I would add, and then I'll show you how to solve. So find the value of c that makes x squared plus 12x plus c a perfect square. What we're going to do is we're going to say, okay, b is 12, right? B is the coefficient of x. That's 12. Half of that is 6. That's step 1. Step 2, I square that. 6 squared is 36. Step 3, I'm going to add it, because my original thing is x squared plus 12x plus c. Now I know that c has to be 36. So now I have x squared plus 12x plus 36. This is now a perfect square trinomial. My first and last terms are perfect squares. The square root of x squared is x. The square root of 36 is 6. Multiply it by 2 and I get 12x. So x squared plus 12x plus 36 is automatically going to be written as x plus 6 quantity squared. The number that goes in here is always the number from step 1. It's b divided by 2, or half of b. All right, you guys try this one. All right, the answer here is A, and there is the work if you need to look at how we got there. Okay, so now finally, notice in this last one I didn't solve. Why? Because it was an expression, not an equation. There was no equal sign. So now we're actually going to solve an equation by completing the square. Okay, so we're going to start by analyzing what I have here. My first term is a perfect square, but my last term this time is not. That's how I know that it's not already written as a perfect square trinomial. I'm going to force it to be one. So what we're going to do is we're going to take c and we're going to move it to the other side. Or really, we're not actually moving it, we're just adding 12 to both sides to make this side equal 0. And then 0 plus 12 is 12. So I have x squared plus 4x equals 12. So then I'm going to complete the square on this side. Follow the same process. So here's b. b is 4. So I'm going to take half of 4. 4 over 2 is 2. And then I'm going to do 2 squared, which is 4. So whatever is half of b, I square it. And notice that 4 got added to both sides of my equation. That forces this left-hand side to be a perfect square. So I can rewrite this as x plus 2 quantity squared. On the right-hand side, I'm just adding. I get 16. Now that I've done the completing the square process, so what did I do? I forced this left-hand side to be a perfect square. I completed the square. So now that I have it written like this by factoring and completing the square, I can use the square root property, right? So let's look back here just again for a second. Now that I have everything on this side inside of something that's squared, I can take the square root of both sides. And that's going to give me x plus 2 equals plus or minus 4, which is what you'll see on the next slide. Subtract 2 from both sides. Be careful that the 2, this negative 2, goes in front of the plus or minus 4. I can't subtract it from 4 because this represents a positive and a negative 4. And then when I solve that down, I get x equals 2 or x equals negative 6. So those would be my two x-intercepts, solutions, roots, zeros. Okay, so the key is, again, take half of b, square it, and add it to both sides. So I move my constant to the other side first, take half of b and square it, like I did here, add it to both sides, rewrite it using perfect squares, and solve using the square root property. So now I want you guys to try this one. The answer here is B. And there's the work if you need to look through what I did. Again, I moved the constant, or I subtracted 8 from both sides to make the left-hand side just look like x squared plus bx. I took half of b, squared it, added it to both sides, and then I did the square root property like we did at the beginning. All right, this is super important. When a is not equal to 1, I have to do one extra step before I complete the square. So notice here, instead of having just 1x squared, I have 3x squared. So what we're going to do is I'm going to divide everything by a. So I'm going to divide everything by 3, every term. And now I'm going to make it be 1x squared minus 2/3 x minus 1/3 equals 0. And then, just like we did before, I'm going to add 1/3 to both sides so that this becomes 0, and I just have x squared plus or minus bx here, and I have my constant on this other side. And then we're going to do the exact same process, just this time with fractions. So what is going to happen here, let me show you while I have a little more space. Here, my b is negative 2/3. So I need to do b over 2. Remember that b over 2 means 1/2 times b. I think it's easier with fractions to do 1/2 times b. So 1/2 times b is 1/2 times negative 2/3, which gives me negative 2 over 6, or negative 1/3. Then I have to square that, right? I have to do half of b squared. So that's negative 1/3 squared, which is 1/9. That is why in the next step they're going to show you that you add 1/9 to both sides. Now the cool thing about this is, even though we're not used to factoring with fractions, we know what the pattern is. I know this is going to be x minus b over 2 quantity squared. What is b over 2? Well, it was negative 1/3, right? If you remember what I had in here, this became negative 1/3 that I squared. So this is just going to be 1/3 inside of here. And then on this side, 1/3 plus 1/9 gives me 4/9, which you'll see on the next screen. And then we take the square root of both sides. Square root of 4/9 is plus or minus 2/3. And so 1/3 plus 2/3 gives me 3/3, or just 1. And 1/3 minus 2/3 gives me negative 1/3. So those two fractions, or those two numbers, would be my x-intercepts. You guys try this one. Okay, the answer here was A. And there's the work for that one. We'll finish